All right, here we go. We have multiple strategies, and we're going to go for not every strategy on the next couple problems. We're going to go for, well, the best ones that we possibly can. And that would be, let's see, direct substitution. Always try that first. Always, always. Can I plug a 1 in the numerator and denominator? Absolutely not, actually. I'd have 0 over 0. Nobody knows what that is, so don't even play that game. That's not cool. So maybe there's some algebraic manipulation that I could use. Maybe I can make a graph or a table. I have given you the option to do all of those. I'm actually going to go for the algebraic manipulation. I'm going to divide this out. There is a rather obscure rule for factoring, and it has to do with the difference of cubes. I'm not going to use it, although it applies here. What I'm going to do instead is a little trick that we all know, and it is called synthetic division. Let's do it over here. So 1. I'm going to divide out x minus 1 by changing the sign of this term right here. It's like if x minus 1 was graphed, I would cross the x-axis at 1. Right. Anyway, so 1, and then 1x cubed, 0x squared, 0x, and 1. This should look familiar from a previous math class. We're going to bring down the 1, multiply, put it there, add. 0 plus 1 is 1. Multiply 1 times 1, it gives me 1. This is not the best example to refresh your memory. Lots of 1s and 0s. It's like a whole problem in binary code. 0 plus 1 is 1. 1 times 1 is 1. Whoops, I have made a slight mistake. I'm going to go with it. I'm going to fix it as we go. Here's my mistake. That should be a negative right there. That makes this a 0. I overlooked that earlier, so if you were following along and you're like, whoa, what happened? Okay, my bad, sorry. So here's what all this tells me. It tells me the whole world is written in 0s, 1s, and negative 1. But it tells me that my reduced form of this, which I will write in, pick a color, black. My reduced form, as I evaluate the limit as x approaches 1, is not x cubed anymore, but it's 1x squared plus 1x plus 1. Okay, basically this times that denominator would give me that numerator. Trust me, it would. It's cool, it works. Again, there's sort of a shortcut for that with the difference of cubes, but it's not relevant in terms of we have to know that to do this, because this works just fine in this context. Okay, is it possible, mathematically legal, for me to plug a 1 in now? Plugging in a 1 never makes me do anything I shouldn't do, like, rob a grocery store or divide by 0. So I have 1 squared plus 1 plus 1, and I get 3. I never needed a table. I never needed to graph. I didn't need any of that. I got it. Graph it if you want, make a table if you want, but I'm not. I don't feel like it. So let's go to the next problem. All right. Always ask yourself this first, is it okay for me to substitute a 4 in everywhere? Yes. This one is super easy. And I tried to trick you by giving you a graph and a table. And we're going to graph it and we're going to do, I can factor. Yeah, you can factor, but don't. Just don't. If you plugged a 4 into the denominator, you would not be dividing by 0. You're good. Plug a 4 in the numerator, you have 4 squared, 4 times 6, and that. And you have 48 divided by 8, and last time I checked that was 6. The limit is 6. Notice when I wrote limit and when I didn't. And what I did do was write a limit here when I had not yet substituted the value in. But here I did not write the limit because I was ready to sub it in, and I just subbed it right in. Okay, let's move on. Let's keep going. All right, here's the front and back. Mine are front only. I wonder, can I use direct substitution? Absolutely, yes I can. Man, these are easy. I love this. Why did I give you all that space with the graph? Just in case you tried it on your own, I guess. 0. Graphs, great. Table, great. Direct substitution, amazing. All right. So this next one, however, is going to take just a little bit of effort on our part as we look at the piecewise function. So I hope you remember beginning of the notes, here we are. When we were talking about this limit as x approaches 2, f of x, we were dealing with this situation where we were approaching, as we approached an x value of 2 from the left and the right, we were approaching two separate y values, and that's bad. That means the limit does not exist. So we have the potential, not a guarantee, but we have the potential for that to take place here. So I am actually going to use a couple strategies. First of all, I could use direct substitution, but for the sake of understanding the concept, I'm going to slow it down. I think we gained enough speed with this problem where we can slow down a little bit on this one. All right, so here we go. What I'm going to do is start with a table, and I'm going to plug in numbers that approach 2. A little speech bubble. You don't have to put a speech bubble. And I wonder what I'm approaching down here. And I might find an answer, and if I do, I'm going to verify it with a graph. But I'm having fun. Work with me here. So I want to approach a 2, and if I approach a 2, I have to get really close to it, like 1.999 or 1.99 and 1.9. And also approach from the other side. So like 2.1, 2.01, 2.001. We're getting closer and closer from either side. And as I do that in this context, in this problem, what I'm dealing with is one specific function over here. And, excuse me, pardon me, another function over here. Grab a sip of water while you're writing. Aren't you glad I narrated that for you? So I have two separate functions because I'm dealing with a piecewise function. I have one rule for things that are less than or equal to 2, another rule for things that are greater than 2. Now, you could say, well, I could just plug a 2 in right here. That's fantastic. Does it work if you plug a 2 in right here? Would they match up? And there's an easy way to do that, but I want to show you this so we can see how these pieces do truly come together. I just went ahead and blurted out the answer does exist. So let's do some of this in our head. X minus 1, if I plugged in these x values into x minus 1, I would have, well, 0.9. And I'd have 0.99 and 0.999. Personal habit of mine, I like to put zeros because, you know, aesthetic beauty there. X squared minus 3, a little harder to do with these numbers, so we'll just type them in. X squared minus 3. You can't see my calculator, but I don't want you to see it anyway. Ha ha ha. Kidding. And we can go to the table and delete anything you have. You can just press the delete button. Deletes it. 2.1, 2.01, 2.001. And these are the numbers that I get. 1.41. Okay. That's pretty far off. 1.0401. Okay. 1.004001. Okay. All right, fine. So then the question is, as I approach an x value of 2 from the left and the right, am I approaching the same y value? So 0.9, 0.99, 0.99. Man, that looks like it's going to round to 1. This looks like it's going to round to 1. So the answer is indeed 1. Like, final answer is 1. That's not how we write our final answers around here. That just demonstrates what's happening in the table. Final answer is 1. Okay, I'm also going to graph it. I will make this quick because I just want to demonstrate what this looks like visually. I want to graph the line x minus 1, which is this. And I will graph that line up to and including x equals 2. So there we go. And then the parabola x squared minus 3 is down here, and it does this thing, it does that, and this is over 2 and up 4, because 2 squared is 4, so there we go, and it does this, and there's that on that side, but it's actually not on that side, so I'll grab an eraser, because this function, this parabola, does not exist less than 2, but it does exist greater than 2. So there you go. Now, we have some we have a jacked up graph here with it's kind of a sharp turn. A friend of mine calls it kajankety. But we have a kajankety graph. But the point is this, that there is a point where we approach from the left and the right, and we got a value. And that value is 1. Okay? All right, shortcut. I wanted to do this for conceptual understanding. Here's the shorty mix shortcut. Plug a 2 in right here. 2 minus 1 is equal to 2. I'm sorry, 1. Whoa, wow. You got to get your math right if you're going to do a shortcut. 2 minus 1 is 1. Okay, I got it. I'm teaching calculus here. And then plug a 2 in here. But it's not equal to 2. No, I don't care. Trust me on this. 2 squared minus 3 is equal to 1. They work. And here's the deal. The closed circle from this function matches the open circle from this function, so they meet up. And therefore, your limit does exist, and that is the y value.